All right, cool. Vector Podcast, episode 2. And today we have Bob van Luijt, the CEO of SeMI, the company behind Weaviate. That's a vector database. And I'm sure Bob will talk more about it, what it is, what it isn't. Hey, Bob.
Yeah, hey, Dmitry, thanks for having me. Cool to be here.
Yeah, thanks for joining. I know you have a
Of course.
hectic schedule, but it's always nice to, pause a little bit and talk about things. And I was thinking maybe we can start off by introductions, like if you can introduce yourself, your background, and kind of like how did you end up working for this product and company?
Yeah, sure. So I started my career as a software engineer, and later I moved to a more IT and software consultancy. And one of the things that I was working with a lot of unstructured data, and we're probably going to talk way more about that. But the story that I have is that years ago I was at a conference in San Francisco, and it was a cloud conference. And back then, it was just announced that there was a change in the Google search algorithm. And you have to bear in mind this predating like machine learning models like transformers and those kind of things. This was the time that I think Glove was the biggest thing around. And they made it change, and they said like, well, we're gonna go more to contextual search. We're going away from what they called then page rank to rank brain. And one of the things that I was looking into is like, is there any company or are these cloud providers, are they going to provide database technology or search engine technology that actually deals with a similar type of search so that it becomes easier to search through unstructured data? And the answer was actually like they weren't looking into it, or maybe they were, but they weren't sharing it. So I was actually at the airport of San Francisco, and I just started to work on this idea. And it was like it's coming from a lot of directions back then. So there was a lot happening. Knowledge graphs were happening, and machine learning was growing. And at some point, I thought like, hey, actually, I do think that there's an opportunity in the market for this. And so I started to work on this. I started to gather a team around me. And what then happened was that a lot happened in the machine learning space. So think about these transformers models were released. They were getting better and better. And back then we were still looking at like having like these vector representations that we can talk a little bit more, about in a bit, like on the side. But we actually learned like, hey, actually, if we use this, we can just solve new use cases, and we can build a completely new database or new search engine. And so that is the origin story. So that's where I'm coming from, and why we started. Because unstructured data was a problem. It is still a problem. And I strongly believe that these kinds of vector search technologies are helping in solving these problems, not only in text, but also basically anything you can vectorize. So there can be images, there can be audio, but that could also be, I don't know, the human genome, you name it. All these things can be vectorized, and it gives another perspective to search through the data. So that's the origin story.
Yeah, that's awesome. That's awesome to hear. And like this field is still in many ways emerging, right? Like the field
Yes.
of, let's say, vector databases per se as products, but also the field of applying them, for different use cases. But like it's interesting you touched on like you knew about Google kind of disclosing something, and then you knew that the models have been also developing, right? Let's say basically you predated that, but then BERT came out, right? And then in other fields, let's say computer vision, automatic speech recognition, they also been vectorizing in some way. Maybe signal processing wasn't vectorizing, but then I guess they started doing it. And like, it's interesting. Do you think that you kind of like coincided, like you basically predicted this field, right? Like you didn't know it will happen. You felt that it will happen, but it wasn't at the same scale as it is now. Today we have so many models, right? Like, I don't know, Hugging Face, making a product out of it and so on. But like, do you think there was a real need, or was it kind of coinciding that, yes, now there are models, we are addressing the similar problems, but using different technique, and now you are there with your idea?
Yeah, so I mean, there are two sides going to answer this question. So on one end, that's more the about the need, and then secondly about when I saw the value. And so let me start with the first thing. So um, unstructured data is huge, and the problem that we currently have with search is that if you know what you're looking for, you can find it. If you don't know what you're looking for, you can't. So to make that very simple, if you have a web shop, for example, just sort of a grocery store or something like that, and you're looking for medicine because you have a headache, then you must somehow or use the name of the product, or somebody needs to tag the product to find it, right? So if you have like, I don't know, aspirin, then somebody has to add the keyword, headache or something like that, or painkiller. And then even with painkiller, et cetera, et cetera. What these models solve, and then we only talk about the NLP, the natural language processing models, is that they solve is that you can look in the vicinity of these words. And what I often give as an example to think about it, just as a mental model, is an actual physical grocery store. So the example I always give is that I say like, well, let's say that I've like I have a shopping list, and the shopping list says like apple, banana, washing powder. If you would have a traditional database, if you would have a store that is organized as a traditional database, then it could be, for example, on an alphabetical order. It's going to be pretty difficult to actually find what you're looking for, because maybe at the A you might not find the apple, but you have to look to the G because you're looking for a Granny Smith apple, etc. And what these vector models do is that they're basically a form of a hyperspace, right? So they have, you can envision them as a three-dimensional space. So if you walk to the fruit department, right, in the grocery store, and you find an apple, then you know that a banana will be closer by than the washing powder is. And if you move towards the washing powder, you move away from these from the fruit section. And that brings me to the second part of my answer. When I knew that this had potential, was because I made this very simple, super simple prototype, which was based back then on Glove. And the big problem was that people say like there's a problem with disambiguation. So if I have a word with a vector representation, for example, the word apple, is that related to the fruit apple or to the company apple? So I did something very simple. I said like, well, if I have a document or a sentence, and again, bear in mind, this is predating transformers. And I said, well, what if I take these individual words? So I wrote a very simple script that took these individual words. I was like, I'm going to calculate a new vector representation, just a centroid based on these words. So now I said, okay, I have a company with the name Apple. So I take all these individual words, calculate a centroid, and now I see if I can somehow make the word, the sentence less ambiguous. And that turned actually out to work rather well. Not extremely well, but rather well. Again, we're talking years back now. And then I knew, okay, here is value, because I could think of so many things that you now can index, and you can search in the air quotes vicinity of it in your vector space. Mm-hmm. It made it easier to find things. It made it easier to classify things, et cetera, et cetera. So that would basically be my answer on how I see that.
Yeah, so it's a great answer. So it's like the way I thought about it, it's like you bring context to your data, right? If we stay yes. on the text side for the moment, you said apple and banana, they are related because they are both fruit, right? Mm-hmm. But there could be some other related items in our data set we just don't know about. As long as we encoded them and with the right kind of distance metric, we can figure it out how close they are. So it sounds like, coming back to your previous example where we have used, let's say, inverted index, we would just store all our items in some alphabetic order and hope for the best. And that order, I think, inherently didn't have the context, right? So the context was kind of it was kind of represented in a different way. Like specifically in the case of inverted index, you deal with a dictionary of terms pointing to a posting list, right? Speaking in Lucene search engine lingo for the moment here.
Yeah.
So, and that posting list is just an ordered list of document IDs. So you don't have much context there either, right?
No, exactly, and that is how it brings context, and again, going back to that mental model, or that idea that you can have about it, is that what I said, like, so if you take the building where where you have the grocery store in the building, the building would be the database basically, and the model tells you where to put stuff in that building. So that's how it's giving that context. And then the only thing that we need to do, well, I make it sound very simple now, but the thing that we need to do in that database is make it possible as easy as possible for the end user to navigate through that building. And that is basically what the vector database is doing. So it's taking the data, and we can also talk a little bit more about the features that we have in Weaviate, because that's also something that we don't only store vectors, we also store data objects. But basically, if you bring a data object to Weaviate, you tell it, take this part of that information to vectorize. So for example, if you have, well, a product, for example, then you could say, well, I want to vectorize the title and description. That is vectorized, and then the model tells Weaviate where in that database or in that vector space to place that data object. And that is what we try to optimize for as much as we can, so that you can search through hundreds of millions of data objects in using that model in just mere milliseconds.
Yeah, that's fantastic. And I think before we move to the kind of what you are focusing on as a product, which is super exciting, and I mean you're doing a ton of work. I just wanted to close off on that line of thought that maybe, just maybe, we are on the verge of closing the inverted index data structure because it existed since, I think, 15th century, like the first book where they published the index page in the end. It's an inverted index because it said, okay, this word occurs on this page. That's an inverted index, right? And so it existed for multiple centuries. And so you think we are on the verge of replacing it with contextualized embeddings?
I mean, that is an exciting thought. I have to know that there are a few things from a technical perspective where the inverted index is still being used. But one of the things that we've done, for example, in Weaviate, is that we said, like, we doubled down on the vector, on the contextual search. And yes, every now and then. So for example, if you say, show me, if you have a product database and you say, like, show me products for outdoor sporting, for example, but they have to be more expensive than $10, then both types of indexes kick in. But it definitely starts from the perspective of vector search, and I like your idea. So the amount of also research that's being released that we of course also benefit from is amazing. So I like that thought. I like that idea.
Yeah, so I think on the next lecture, I also a little bit like teach students in the local university here. And when I explain some basic building blocks of sort of, classical search engine architecture, and I explain the inverted index, then I puzzle them with this question. Do you know how old this data structure is? And the students are actually from the linguistic department. So they are not as kind of, IT people who care only about code. They also care about the rest of the life in many ways, right? So they know other things. No, I don't want to downplay the IT guys, but I'm just saying they are kind of very multidimensional, and they're just puzzled, and they say, okay, maybe 18th century, they don't know. But then I just bring the screenshot of a really old book, which is from the 15th century, and they're like, really? So I sort of make that connection that, hey, we are still using the tech that was invented in 15th century.
Yeah. No, but I mean, I agree with you, and that is extremely exciting, and I think we'll also get into that. But what you also see emerging is like the use cases where those kinds of database and search engines are good at are kind of solved. I mean, of course, it's software, so it can always be better and always be more, but those are kind of solved. But what we see actually with these vector search engines is that new use cases and new opportunities actually pop up, so we can do new things with it. So, and I think that's very exciting as well.
Yeah, absolutely. That's an exciting way to kind of approach this new emerging field is to look for use cases. And I was really wondering, like, what is it that you are building in the company, your Weaviate database engine? So you said that you had an idea, you started assembling the team. Now you give vision, you drive a lot of things on the open source, you're super active. What is it that you are focusing on, for your users? And maybe you can also go into use cases part.
Sure. So it's important to bear in mind that if you look at a solution like Weaviate, you can take two angles to look at it. So you can, as I like to call, you can look at it bottoms up. So that's really through the core technology. That's how you can look at it, but you can also look top down at it. So that is from the use case perspective. And there are people working on Weaviate, and as you mentioned, it's open source, that are working and talking about like this from the bottoms up approach. And I like to take a little bit more a top down approach. So just like, so what are the things that we can do with it? And so let me explain to you what we're building. So at the core, so you can see there's like they're like 3 layers basically. So the first layer is the database itself. So you can find that database on GitHub. You can find it on the documentation on our website, and it's just called the Weaviate vector search, and it's the core database. We see people use the database just to store data objects and their own vector representations. Now, what is very important to know from a use case perspective, and I'm now starting at the lowest level, is that we thought that it was very important from the get-go to make sure that people can not only store the vectors, but also the data that they are representing. So back to an example of the product, but it could also be an article or what have you. You can actually store the product. So the price, the name, the description, and those kind of things. And you can say, this product has this vector representation. And on top of that, we also said, like, we want to be able to connect these data objects together in a more, air quotes, traditional graph format. Just to make sure, so Weaviate is not a graph database, but it has a graph data model. Now, when we go into use case, I will share a few cool things that you can do with that. But that is at the core, at the heart, that is the database. And what does that database focus on? It's focused on being a database so that you can real time have create, write, update, and delete functionality, which is easier said than done. And there's a lot of content also that my colleague HN talks about online if you really want to get into the nitty gritty. So, but it's data. So the database that you're used to, you use Weaviate in a similar fashion. So you take the container, you spin it up, APIs become available, or the RESTful APIs of the GraphQL APIs. We have clients available, Python, Go, Java, what have you, that you can connect to the database. So if you're used to working with a database or a search engine, it's the same functionality there. That is one that sits at the core. Then around that, we have our first layer or a second layer, and those are modules. And what these modules do, they do a few things. So we've seen like, hey, there are actually certain types of, for example, machine learning models that people keep using over and over to get these vector representations. Why not bundle them? So think about the text to vec models that we have. So we have different types for different use cases where you can say, well, I'm going to throw in that product, but automatically take a model to create a vector representation for that. So that's something that we have, but we also have question answering models, spell check models. You can create your own models. Sorry, I'm saying models, I meant modules. Sorry, this is a little bit, and it's so models and modules. So I meant the modules. And those are available open source as well. And my colleague Lara made a great video also on like how you can build your own modules. And then we have like another layer around that. And then we go a little bit outside of the realm of the software per se itself. And those are more in the packaged use cases that we see. So we see that there's a lot of value in retail, wholesale, e-commerce, in the medical space, data management space, those kind of spaces. And what we're doing, and that's mostly also my focus, is saying, okay, if we have at the core, we have this one singular database, what are these packaged things that we can do around it? And that is also where we make a distinction between our users and our customers. So our customers are mostly interested in these packages where they can say, okay, I have a ERP classification problem. Oh, great. You can actually do that with Weaviate. We have that specifically for companies in your industry. Can also be for document search, for a medical use case, image use cases, image similarities. And so we package them together. So that would be the last layer. Sometimes there's software involved, for example, in the form of plugins and those kind of things. But that is the outer layer. So that is what Weaviate looks like, and that's what we're constantly building. Because as you mentioned before, vector search is kind of a new thing, right? To actually deal with that. And now the question might be is like, so what's actually the new thing, right? So the other day somebody asked me, he said like, well, it was a data scientist. He said like, well, but if I have my vectors, I can just store them like in my memory and do some similarity search on them. I said, yes, you can absolutely do that. I said like, now, but what if you want to do that for a product catalog that might have like 50K products that are constantly changing and those kind of things? So then that becomes problematic. So we actually help you to bring these models to production. And what you actually see is that the new use cases that come out of that are tremendously big. And we're just constantly uncovering new ones. So let me give you one example. So let's stay with the e-commerce example. So if I have in Weaviate a data object that has a product, and a product has a vector representation that it got from a, for example, transformer model, then we can also say in Weaviate, well, I have a cart, right? Just a shopping cart. Now, if people add products to the shopping cart, we can real-time calculate new vector representations based on what people have in these carts. So now we can say, hey, based on what you have in your cart, you might be interested in this or that product as well. So now you have these real-time. Now, all of a sudden, it changed from a search engine where you can find products into a recommendation engine for e-commerce, just all in one. And those kind of things we're constantly uncovering. And there's so much more that we can do from very concrete things like e-commerce to on all the other end of the spectrum, things like with vector representation that people are calculating for like genomes and those kind of things. So that keeps just these use cases keep turning up, almost on a daily basis.
Yeah, that's I want to that's so great. Like dive in. I was kind of a little bit I wanted to unpack a little bit like things so I understand them well enough, and maybe our listeners will too as well. So like when you said models and modules, let's say I'm a researcher, I have a model, embedding model, right, that I've been using and battle testing. Now if I want to introduce that model into Weaviate, I will have to create a module which is using this model. Is that right? Or is that?
Yeah.
Okay.
That's correct. Yeah.
And to do that, I need to extend some API, right, that you provide.
Yes. And that is something that we spent a lot of time on, and that's the API design. Because I am a strong believer in developer UX. So it needs to be as clean and as easy as possible. So one of the things, for example, that we've done is that we've adopted GraphQL as an interface. So sometimes people ask, they say like, well, why GraphQL and not something more expressive like Sparkle or something like that? Which is a good question. But one of the things that we know is like, well, if we focus on being a vector database and we just want to show these data objects with their vector representations, and sometimes if possible we'll have these as these graph connections in them, but we're not focusing on being a graph database. We think actually GraphQL does the job, and it's easy for people to understand. It's very intuitive for people to understand, and I think that these kind of things are very important. And so to get back to your point and to your question, so what we try to do is make it as easy as possible to actually bring these, if you have your own models, to production. And if you're like, well, I don't have any models, but I just want to do, a semantic search through, I don't know, resumes, right? Then, just pick something off the shelf, shoot it in through the API, and you're good to go.
So let's say, and also this is kind of like, which I think is very important in today's world, even though a lot of machine learning and data science happens in Python, when you go, let's say, to web scale, sometimes
Yes.
you cannot use Python anymore. Like you need to use, let's say, Go, right? Or maybe even C bindings in Go and things like that. So your API, is it kind of cross-lingual, meaning I have my model in Python or maybe in Go? Can I kind of plug it in? Or do I need to rewrite some layer on top of it to be compatible with
Yes,
Weaviate?
that is a great question, and here comes the especially the expertise of the development team in. So the what they've done is that they say like, well, we know that that center, right, that database, that just needs to be optimized as far as possible, because let's stick with the e-commerce example. If you use it in production and hundreds of people are searching and you want to give these recommendations, you need to be able to scale it. So you need to choose a language and an architecture that actually supports that. So in our case, that's Go. But even if you look through the GitHub repository, you will even find assembly optimizations for certain things in there. But we also knew that we said like, well, maybe if you want to use a model that's written in, for example, that has bindings in Python, for example, or you like to work in Python. So one of the things that we did there is that we said like, well, the way that the modules work is that the modules are containerized. So there are APIs going between Weaviate and the different modules. And as long as you adhere to these APIs, you can choose whatever language you want to build a module. So in the case of Weaviate, Weaviate itself is completely written in Go, and it's like even with the assembly optimization, those kind of things. And the modules, we have a few modules that are, for example, written in Python, because we use specific types of transformer modules that just run well within Python. So you can do whatever you want within it. When it comes to using Weaviate, so you have the database running, and you can pick a client, for example, the Python client, and have the Python client interact with Weaviate wherever it sits. But if you're building a front-end application, people use, for example, the JavaScript client. So I've seen people build React applications with the JavaScript client. So that's why we structured it like that it's easy to use in production.
Mm-hmm. Yeah, that's amazing. And like what you touched on, it's so important, and I mean close to my heart as well. I've been building APIs kind of in my free time for a long time, and like what I've noticed with the users is that the lower you put the boundary to kind of enter, right, like meaning let's say you have an API and you have published the sample clients to use this API on all possible languages, let's say kind of the mainstream ones at least, it will lower the threshold to enter for them, so that they will never even contact you. They will start using it, right? That's the win. That's the win, right?
Yeah, and I even believe so to sidestep a little bit from the discussion, but it is interesting to talk about this, because I am a strong believer, and I'm tooting my horn for like years already about this, that is like the overlap between the tech and the business side is, in my opinion, expressed in the API layer. So if you peel the onion of a tech business, you can go as deep as Go, unless you have a graphical user interface. But if you talk about database technology, those kind of things, even bigger platforms, if you look at the API describes to you in human language what it's exposing, and therefore what the value is that it's creating. And then the only thing that you need to do as business is try to capture that value.
Yeah, exactly. And it's like, I think the sort of the saying behind the API platform I was using back then, they were saying like, software is eating the world, but APIs are eating software. So they like decomposing the software that was sitting on the shelves somewhere in those big companies, small companies, whatever. And now it's introducing the network, right? So like everyone wants to expose their value through an API, and you can easily consume that value through an API,
Yeah.
right? And then you add all these, payment, layers and whatnot to actually make it economically feasible. But that's I think that's an exciting direction, and I'm happy to hear that you guys are pursuing that model, like basically making it an API. In many ways, database should be an API, right? It's sitting somewhere, and I can connect to it with my client in the language of my choice, and handle all the cases I need to handle.
Exactly. And I think so if you look at a nice car, for example, right, there are two ways that you can look at the car. So the bottom up way, if you compare it with software, right, the bottom up way is that the first thing that you do, you open the hood and you look at the beauty of the engine, and maybe you want to know how the engine works under the hood. The top down way of looking at it is just opening the door, sitting in the chair, holding the interface of the car, the steering wheel, and you go like, oh, this car drives, it drives fantastic, it drives amazingly. And my argument personally is, and not everybody agrees, but that's my point of view, is that I say, like, if you have an amazing engine, but shitty steering wheel, nobody's going to drive your car. I mean, the other way around is also true, that if you have a beautiful interface in your car and you have a shitty engine, that also doesn't work. But that needs to play well together. And that's again why I'm a strong believer in the UX, the experience that you have in using the technology, because of course an experience is not limited to a graphical user interface. They can also sit in an API, of course.
Yeah, absolutely. Like coming back to some of the use cases you brought up, I mean, you mentioned the shopping cart. I was actually chatting to Eric Pugh. Hey, Eric, if you're listening to this, from Open Source Connections, he was saying like out of his, it's kind of out of blue sky, he was saying, hey, so let's imagine a use case. It's a pizza delivery and you want to encode the journey, of your delivery person with no left turns, right? So like only rightmost or right turns or, forward, backward, but no left turns, just for whatever reason. And this was like a very interesting use case. Like, can I actually express that in the form of embedding? Probably I can, right? So, and do some kind of geographical search and like say, okay, what's the most similar sort of journey that will bring this pizza from A to B? Sounds a little bit crazy, but like that's what I'm thinking when a use case exists. The sort of the journey is to go backward from it to the embedding space, right? And that's very interesting.
Yeah, but so let's build a little bit further on the. So I like the example, right? But it's a good example, but it's an abstract example. So we might even make it a little bit more concrete, right? So let's say you have a pizza delivery service, and from the moment somebody orders the pizza, you have certain data, right? So you have data about like what's on the pizza, where the pizza is coming from, where the person's living, etc., etc. There are two things that you can do, right? You can encode that information in a vector representation. And if you are fast enough in comparing vectors with old orders, you can say something about that order. And then it becomes interesting. So what you now can do is that you can say, for example, you might be able to say something about delivery times. So you can say, okay, we've sold, let's say that you're like a big pizza chain, we've sold like a million pizzas in the past. Now based on this request, we real-time calculate the vector representations for this order. We do a real-time comparison for orders in the past. And then we said like, hey, we see that the average of the last, 10 orders that are similar was like 18 minutes. So now real-time, you can say something about that. So this is just an example of a use case that where these vector databases might be extremely valuable. And that's just a example. And that just more and more of these kinds of cases are popping up. So that's extremely exciting, in my opinion.
Yeah, I mean, it sounds so interesting because there are so many products that still revolve around the idea of, let's say, kind of for simplistic terms, inverted index. Like I'm using that 15th century model to represent my data, right? Then if I have images, I'm like, oops, what should I do now? Okay, maybe I can use some extension on top of Lucene if I'm using Lucene, let's say for the sake of it, right? But it's still kind of a limiting experience. It's kind of like, okay, I'm solving my task with the wrong tool, right? In many ways. And maybe I should not be like, let's say Lucene, since I mentioned it, I can kind of continue using it for the sparse search, for the normal inverted index retrieval, but I can unlock so many new use cases with the vector search, right? And like find kind of new ways to show the value to the users, because especially, you know, like in traditional search engines, if you return, let's say 100 results, you know, users don't have time sometimes to go through them, right? You basically offload a lot of, do you feel that way? Or
Yeah, certainly. And there are a lot of interesting things in what you're saying. So I mean, so again, it depends on how you look at it, bottoms up or top down. So you can make an argument from the bottoms up approach, that you say, okay, we have the inverted index, or we have the vector index, and we can do certain things with this. But what I also like to do is that I like to look at it from a top down perspective. And what I mean with it is this. So um, if you work with you want to build on a project for yourself, you want to build on a project for, you know, with your students, you want to build on a project for I don't know, for your boss or for a customer, whatever. How often do you actually say, like, okay, the tool that I'm now going to use to store my data is an inverted index? It probably doesn't happen that often. I mean, it's like if you go to one of the websites of these famous big companies that build databases around inverted indexes, they don't go like, this is the best inverted index around, use us. They say something else, right? So they say like, hey, we help you with enterprise search, or we help you with logging, or we help you with cybersecurity needs and those kind of things. And what I think where we are right now in the cutting edge of like where vector search is like, we are talking about it like you would be talking about these inverted indexes. But I hope, and that's one of the things that we try to do at with at SeMI Technologies around Weaviate, is to also talk about these new things. Like, this is what you do with it. So it's like, hey, you can now, you have like these recommendation systems in e-commerce. You can do contextual search in e-commerce. I don't know why I stuck with e-commerce, but I keep getting, or you can do contextual search for documents and those kind of things. I was talking about this amazing use case that had to do with with a resume, and it had to do about this. So there was like, you have a resume, and let's say that in the resume it says like, I'm an IT director and I played in the National Olympic beach volleyball team. That's what it says. And now the request is like, they're looking for somebody who's an IT director and who is interested in playing sports. You're not going to find that person with an inverted index. But instead of talking about that from the perspective of like, the inverted index can't find it because there's no relation directly between sports and being in the Olympic beach volleyball team, but with the vector index we can. I actually like to find more words and better language to actually talk about these from the perspective of the use case, like contextual search, semantic search, and those kind of things, which I even think are still abstract into a lot of people's ears, but I think it's also very exciting. So there's this new thing, goes for you as well, right? So you're also helping with that. You're helping to let the world know, like, hey, look, there's this new thing. Look what the things are that you can do with it. So I think the point that I'm trying to make is that it's not that I disagree with your point. I agree with your point. But if we compare it with successful search engines now, that might be based on inverted indexes, but that's not how we talk about them. And I really think that we're like at the cusp of that change, that people say like that they start to talk more in these from the perspective of the use cases and the things that you can build with them.
yeah, absolutely. I mean, it's just, like my engineering mind always kicks in and says like, hey, but you are basically offering me to replace inverted index with like vector search data structure. But you are totally right. Like if an electric company would say, hey, buy our cars because we have the best battery and look how good it is, and they supply some diagrams there and showing how well it conserves the energy and stuff, right? Maybe it will appeal to some clients who want to save the planet, let's say, right? But the rest of the clients, they will say, okay, why should I buy your car if it's slower, right? Like you didn't focus on the use case I'm kind of like advocating for, right? So, and you should always listen to your users on that front.
Yes, and so what you're saying is very interesting, and this is something I was inspired by something which is called the layering problem, which basically means that in the past, and I was, so this was for me the case too, like I think like, you know, maybe 10 years ago or something, that the user, if I just go deeper, drill down deeper, and I understand how something works at the core, that means that I understand the whole concept of something. And the more I'm learning about this and the more I'm working on it, the more I think that that's not the case. So let me give you an example. So there was this, I saw this tweet coming by on the day that Coinbase did an IPO. And I'm paraphrasing here what was in the tweet because I don't remember exactly, but somebody found the Hacker News post where somebody announced that they were working on Coinbase. It might not even have been called Coinbase back then. And he said, like, hey, I'm thinking of building a platform, blah, blah, blah. It's something like that. Well, you should have seen the responses there, because people are like, no, who wants to use that? And that's not what these blockchain technologies are, you know, made for, because we actually want to decentralize things, blah, blah, blah. Regardless of the fact if you agree or disagree with the statement, I think we can agree on the fact that Coinbase is doing pretty well and bringing a lot of value to people. So the point that I'm trying to make with this story is that I think that the risk we run in constantly doing that deep dive and making the deep dive comparison, which is important and which needs to happen, and where we need to think on in the product development, we also need to think in these other layers, like how will people actually use that? Because don't bear in mind that the people currently that are involved in the discussion talking about these vector databases and who are very vocal about it are people who are extremely knowledgeable about what's happening in that hood. But what if you're just you're just working at a company and you're just like a normal software engineer, and somebody says like, hey, I want to do better product search, and you do a Google search on that, you find a solution like Weaviate. You might be interested in knowing what's happening on the root, but there's a limit to that. You also you come to it through the use case, not bottoms up. But that's how I look at it. So that's the point that I want to make.
No, I really like your approach, Bob. Like, because I mean, I was kind of joining this industry, entering this industry as an engineer, and then I kind of progressed more like to work closer to product management. I didn't become a product manager, but when I talked to them, they really kind of want to hear too much about the algorithms, right? Because it's not what they think about daily. They think about solving user use cases, right? And sometimes they may ask, how can I do this? Is this possible? Right? And they give you a task, right? And then you go and like, you come back to your toolbox and you're like, okay, what do I have here? Couple of databases. I have this queue system. Okay, let me stitch things together and maybe this will work out, right? But I agree with you that I think in many ways we have that risk kind of in engineering, kind of focusing too much on what's closer to us, right? Let's say I enjoy using this IDE, I enjoy using this compiler, but what value it produces beyond me enjoying using it, right? The end result, right? That's
Yes.
what matters. Right?
No, absolutely. And don't get me wrong. So, I mean, sometimes when we have like on our internal Slack channel, when there's something new released in the software, or then I enjoy that as well. And or I can, then I play around with it and I go like, oh, it's amazing that this works, or that we can do this, or how fast things are, or how scalable they are. Don't get me wrong, I enjoy that a lot. But the things what I also enjoy, and I think that's also the role that I have in this company, and the role that I'm trying to play for us when it comes to vector search, is if you, for example, have these product managers, to actually listen to them and say, okay, what problem can we solve? And I don't think it's the responsibility of the product manager, to take an example, to understand how vector search might apply to their use case. No, we need to be able to express to the product managers how we can bring value to them. Because I don't think, I mean, of course, there are product managers that say like, okay, for the next product, we need a Cassandra database. But I don't think there are many asking that question. They ask a question like, okay, you know, we can absolutely, it's a lot of data. We can never lose the data. Architect or engineer, how are we going to solve that? And it's different language to talk about these problems. And what we now start to see is that there's this wave coming that people express problems from a product manager perspective, business owner perspective, entrepreneur perspective, that they say things or problems that they have. For example, hey, somebody keeps typing in, I'm having a headache in my search bar, but they don't see aspirin. And then we need to go, boom, that's use case for Weaviate.
Yeah, absolutely. And it's like, that's a great segue actually to the second part of our show. You know, like product managers answer the question, what we're building, right? And engineers answer the question, how. And so I wanted you to kind of go and talk a little bit about how you implemented Weaviate. And I understand that Etienne maybe could also talk about it. And I think he talked about it recently in a podcast.
Yeah.
I'll make sure to link that in the show notes. But what caught my eye, and you know, if you look at the landscape of the vector databases, some of them are closed source. Most of them up to now are open source. And it's interesting distinction because some businesses decide, you know, we will keep it close because it's at the core of what we offer. And, you know, maybe there are some risk elements involved for them, maybe something else, but that's their choice. Your choice was to open source Weaviate. Can you talk a bit more about it?
Yeah, sure. Yeah, sure. So so that goes back to what I said, like, if you have a use case, you can package things together, right? That goes from the lowest level of the technology. So just, you know, where the bits and bytes begin, and then where the index sits and how it works and how it's optimized and how it's scalable, and then you go up and up, and then you get to these modules that you might want to use, and then you get to these packages of additional tools that you might want to use for a specific use case. And then the question sits like, okay, where does the most value come from? And what do people need to actually use this in production? And what you try to do is that you try to somehow capture that value. And then there are two things that we see in the case of Weaviate, because Weaviate, of course, all these, also with our competitors, we evolve in different directions, right? Which is good, I think. Is that we said like, well, there's a lot of value. So if you look at our enterprise customers, right, what's very important for them is that that they want to have certain SLAs, that they want to have certain, sometimes they want to have a SaaS offering, sometimes they want to use things that are in these packages, sometimes they want to have specific models. They all can do that. But that is where the most of the value for them is coming from. They need Weaviate to do. It's always with Weaviate at the heart, but it's seldomly that people specifically ask for that vector search engine. So if you go back to that example what I gave, like these famous search engines that you now have around are not promoted as like, we have the best inverted index piece of software that exists. That goes a little bit the same for us. So then you can say like, well, if that's the case, we could consider open sourcing it. And then you can say, well, I can make a pro list and I can make a con list of open sourcing it. So because I have a business model, right? I know how I want to build my business. So what would be a pro of open sourcing it? Well, one is transparency. So you say like, well, we're building something completely new. It sounds all very fancy. We're going to show the world that we're not, you know, we can actually do this. So I very fancy told you like, it's like, well, we even have parts of assembly in the code. Well, you can actually see that, right? So you can see how it's optimized. You can see how it's functioning. That's one. So what that has as an effect is that it builds trust. So the second thing that happens is, as I mentioned before, we need to learn what these use cases are that people are building with vector search engines. So we see people are building like crazy. So our downloads are going up over time. And the other day, somebody just published a great article about how they index 60 million data objects in Weaviate. we're open source users, but what we learned from that, we have this. It's like they're so kind to. They're basically promoting Weaviate. They gave us feedback. They gave us help, etc. But there's also another thing. Sometimes an open source user finds a bug or finds something, and the way that, of course, that the software ecosystem is structured is at the moment that a fix comes in, our customers have that fix as well. So it's a win-win. So, and the thing is, customers don't mind that they're open source users, because if I have a customer that says like, hey, or prospect says, hey, Bob, can I also use the open source version? It's like, of course you can. But if you manage it yourself, you're stuck with the open source license if something goes wrong, and you can choose the SaaS offering. And then they go like, well, we want all that. So then it's interesting for them to buy the license. What's also important to know is that these companies like ours, we're young companies. So you also try to position yourself in the field, and you try to show what you can do. And I think that open source is an amazing vehicle to do it, because as you probably know, the open source community can be very direct, and that is great because then you learn from it and you can make things better. So we've learned a lot from the community. So all in all, it's currently it is a net win to have it open source, and it's because it's helping us from an outreach point of view. It helps us to build community, and it's not biting our business strategy.
Yeah, that's well put. But I wanted to still come back on the open source a little bit. Like you did mention these key elements that are net positive for you, and they natively embed into your business model, so to say, right? Mm-hmm. But there is also one element that the open source, like if you compare this to closed source, let's say the way this would look inside your company is that you have internal, roadmap planning, and you chug along just releasing stuff, right? And then you go directly through your sales, to upgrade this installation. So you become like a kind of corporate type of thing, B2B deployments, right? Mm-hmm. On the open source side, you need to do an upfront work to maintain the connection. You've built the community, but you need to keep talking to the community, right? That's a lot of work as well. So how do you see that part of the story?
Yeah, so that's a very interesting question, actually. So the so what you see with the so in the end, I think that community is not something that is just a open source thing. So let me give you an example. A database company that I find very interesting, just how they operate, is Snowflake, right? I can easily say that because of data warehouse, no vector search, so I can easily say that. No, but so I find it very interesting. And I sometimes talk to people and they tell me, what's an amazing company in how they build, help us build partnerships? That's Snowflake. And I go like, wow, that's interesting. So they explain to me how they do it. So the point that I'm trying to make, they apparently are doing a great job in building a community, but they're of course completely closed source. So you need to build a community, either way. You need to have, if people don't like your stuff, they'll move away. And we know of a very famous database company where that is happening. And so it's it's an old-fashioned company, so that's fine. But that we actually learned from them, like, hey, actually, you want to have a community, you want to be nice, you want to be great products, because then people, then the best marketing is basically word of mouth. And so the point I'm trying to make is like, I don't think we're limited to. Sorry, I meant community is not a thing only for open source. You somehow want to show value, and then you build community by people using your technology, saying something about your technology, etc.
Yeah, I mean, absolutely. I mean, it's just the I guess the essence of my question was kind of like, like if I if I maintain it as a closed source, I can maintain my own standards and I can be, let's say, SOC 2 compliant, right? For the auditing part of things. So my business moves forward. But when I'm open source, I need to maintain a different level of standard, like documentation, code style, the process of submitting, pull requests, and how can I influence the Weaviate direction and other things, like it's a lot of support on your side. You basically, you support the clients, right? Like those that choose your deployments, your hosted version, your cloud. And then you need to support the community. And I mean, I'm not saying this is a bad thing. I'm saying this is like a portion of your business model, of your day-to-day life that is dedicated to that. And you are doing a great job at that, by the way. I'm like super amazed, like
Thank
how
you.
positive you are, always like welcoming on Slack. And the count keeps increasing like regularly. When I go back to the Weaviate Slack, I'm like, okay, just a few weeks ago, it was 150. Now it's over 200. Like what's going on? So, Bob is doing a great job, and the whole team. But I mean, it's work. It's work. That's what I'm trying.
Yeah. Well, I mean, running a startup in general is a lot of work. But I hear your argument, but I'm just not. I don't 100% agree with the argument. So let me explain. Let me explain why. So first of all, like with the SOC, a simple example is SOC 2. I don't know if everybody knows what SOC 2 is, but those listening to the podcast, but it's the same, right? You can have an open source product that is SOC 2 compliant, which is interesting again from a business model perspective. So you can say if you use this software open source, it's not SOC 2 compliant. But if you use the exact same software with a different license, it is SOC 2 compliant. So it's a part of the open source business model. So that's one thing. The second thing about, for example, maintaining the documentation, that is true. But the thing is, if you have a closed source solution, somebody somehow needs to use the APIs as well. So you still need documentation for it. So you still need to maintain that documentation. So so there, I'm not sure if that argument still, if that argument still holds. The only thing that is sometimes difficult is that people ask a lot of questions. So you sometimes see those on Slack, they ask a lot of questions. So you want to be friendly and you want to, you want to answer these questions. There are two things related to that. So one is like at some point, of course, occasionally people ask like a lot of questions and they keep asking over. And then sometimes you friendly say, maybe just watch this video first or read this part of the documentation first. Or sometimes I also do that in a DM and just kindly just, direct them in. Say like, maybe you want to start there. So that is one thing. There was something else that I wanted to say related to this. And the second thing, and it's also something that I always tell the team, is like sometimes an open source user might ask complicated questions, not complicated as in that the question itself is complicated, but just another question. Or why is he or she asking this? But the thing is that I strongly believe that every question that you get has a core of truth to it. So if somebody makes a fuss about something, if somebody asks a question, then probably others have that problem as well. And the upside that you have from open source is that there's a lower barrier to entry. People start to ask these questions, and you learn from them. And I think it's completely fine to, in return, I sometimes, if people ask specific questions, I just ask them, not on the public Slack, but maybe in a DM Slack, hey, may I ask, what are you building with Weaviate? Because then there's this feedback loop and we're learning from it as well. So it's I hear your point, but I do think that open source is evolving and the business models around it are evolving as well, and we're trying to benefit from it. And again, for now, it's a net positive.
Yeah, thanks, Bob. And it's very clear. The reason I'm asking these questions is because there's always something behind your choice, right? And it's like it's supporting your idea, you driving it, but there is an alternative model as well. You didn't consider it because you didn't want to go that path, right? You didn't want to go the closed source path for your database because the way you, as you said, you want to get more feedback loops, right, with the community. You want to learn more about their use cases. And this is a fantastic way of getting it, right? Like you show it just transparently on the web. You can either download it and host yourself, or, and probably that will happen when you run into some issues here and there, we will be there to support you, right? And you can contribute back if you get inspired by the tech itself. You're deep in tech, you want to fix some things, right? Or introduce a feature that is missing, right?
Yeah,
So,
and don't get me wrong. So I don't have any problems with closed source. Even if I mean I can make an argument for closed source as well. Um, um, but I do think is that it plays a role in your identity as a company. So what kind of company do we want to be, and how do we want to show that to the outside world? And yes, that comes with the complexity of needing to deal with it. But in the end, it works well. So for example, we also see, so go back to these product managers, right? So what we see is that sometimes you have developers around the table, and if developers see that they sometimes, especially with corporates, the developers expect that we have a closed source solution. So then they see Weaviate, they see there's actually open source. That makes them very enthusiastic about it. Like, this is great, and I did installation, I played around with it. This is great, which is then a positive feedback loop back to the product manager, and then everybody, and everybody's happy. So it's a it again it's currently a net positive. And also, I think when you build something new, so you try to a new niche, yeah, you create a new niche, and we're not alone, but it's also not very crowded, right? You need to somehow show the world what that niche is and what that niche can do in as many ways as possible. So I think that I dare to bet you a nice bottle of wine that for the 10 people that told me that they really like the fact that Weaviate is open source, only one of them actually looked at the software itself, right? Went in the folders, looked at how it was written. People do that, and people get feedback on it. But for a lot of people, they just think, "Hey, this is great that you're so open about it. We got you. What you're, we understand what your business model is. Great. This is working for us." So it's building it's a friendly way of approaching the market, basically. I
yeah.
would argue.
Yeah, and I think to close off on this, like in my previous company when we were extending Solar, Apache Solar,
Mhm.
the reason we were extending it is because we had a very specific use case that wasn't solved by the community, right? And like as you go into the Apache Solar documentation, you couldn't find a lot of material there on that specific topic, right? And so what I had to resort to is reading the source code, right? And this is something that actually one of the Elasticsearch book authors, I think Rafal Kutz, said, if you have a question and nobody answers it on the mailing list, or documentation doesn't have an answer, go and read the code. That's your
Yeah.
answer, right? And if it wasn't open source, what would I do? I would have to engage through some sales loop, or what? I would kind of like it would put the threshold to enter it so high that I would just kind
Yes.
of unbearably high. I would say, okay, I will find something else, or maybe I will stop working on this problem, right? So
Yeah, exactly. And just knowing that that's there, even if you don't need it, often works as a benefit. What I don't have is, and that's surprisingly a lot of people ask me this, but I don't have any moral reason to have something open source. It's something just that works very well for us and how we want to position ourselves. So, but it's a great question. But I think to recap it, just to position a vector search, and with that Weaviate basically in the world, to show people that this is something that they can do and that they can use. I think it's working wonders.
yeah, absolutely. And maybe we can kind of cover another topic that you've mentioned, that you are using at the core of the Weaviate, you're using certain algorithms, for the vector search itself, like building the index and the search algorithm. And you have mentioned to me in private that you are using like HNSW, which is a hierarchical navigable small world graph algorithm, right? That you have customized, right? Can you talk a bit more why you did it? Like, and you did mention crude, right? So that you needed to add crude. Yesterday I was checking their repository, and they actually the original authors, they already added CRUD there, because probably there've been some other use case coming from elsewhere, can you add it? And I was coming with my new use case, by the way, that I was saying, can I load the first layer of the graph somehow with one single call in Python? And then I had to go and read their code. This is another beauty of the source code. I can read it, right? But can you talk a bit more why you customized HNSW, and did you implement it in Go in the end?
Yeah. So two parts of that. So I did not do that implementation. So we earlier referred that other podcast. So if listeners really want to go into the nitty gritty about it, then I would highly recommend listening to that podcast. But I believe that you're also going to link it. So and the answer to your question was basically already in your question, right? So the thing is that the problem that we needed to solve is that you can take an ANN library, but some of them are immutable. And then the problem is then if you change something, you need to rebuild it again. That is something you don't want in a database, because if you go back to that use case of, for example, the recommendation engine, you somehow want to real-time add a product to a cart and somehow real-time want to deal with that. So then you are, air quotes, limited to an algorithm that supports that. And that was, for us, HNSW was the right fit. However, as you can actually see that also in our documentation, we not only have modules, but the ANN is actually also a plugin. So currently we only have HNSW, but there's no reason, we're looking at others as well, that in the future we're going to release other ANN plugins as well within Weaviate, that you as an end user can actually choose what you want to use. But the requirement that we have for such an algorithm is there basically when you say okay, we need to somehow have that CRUD support, or we need to add CRUD support to it. Could even be the case that in the future it's we're going to support other use cases where that's not the case, but that's for now. And to the second part of your question, yes, that's actually customly built, which you can of course see in the GitHub repo. You see, full circle. Yeah,
absolutely, and that's the value all along, right? So, and hopefully, like in the end of the day, it's like if you guys invent something in part of HNSW that you implemented in Go, and you published it as code, the original authors may also look at it, right? And they might take that idea and bring it back to their implementation, and then that,
of course, yeah.
Just as a side product will benefit some other part of the community, but you will be there as well, right? Because it's the authorship or the credit that will be given to you because you did it, right? So I mean that's very interesting. Like you can benefit and reach out to even like new users potentially, right? Or they will know about your existence through this link. And
no, exactly. And I think so. And the thing is, what happens with a solution like Weaviate is that it's like, yes, it has that ANN algorithm at its heart, at its core, but there's so much around it with the scalability capabilities that it has, with the way of also storing the data objects, that actually building that yourself it's very comparable to, for example, Lucene and Solr, or Lucene and Elasticsearch. So how I like to talk about it in a comparison is I say take the ANN algorithm as in your mind as Lucene. I mean the comparison isn't 100% correct, but to make my point, and then that whole thing that, for example, Solr or Elastic build around it, that is what we're trying to do with these algorithms. So that's how you could kind of compare it, right? Roughly. Just that we say we give you this out of the box. But I do want to reiterate that yes, we have these power users that really want to know that nitty gritty, that want to make those changes. But the majority of users, I like to call them the silent majority of users, they just have okay, I have 100,000 documents. I know a Hugging Face model that I like. How am I going to quickly search through it? Period. And then they find Weaviate. So it's that's the majority of users, and they probably don't even know what HNSW is. which is fine, right? So that's perfectly fine because they do other things. They might be, that's that layering, what I said, like they just sit in another layer that they look at it. So I think the cool thing of our modular system is that we can make these power users at the core happy, but we can also have these more generic developers or full stack developers, we can make them happy, or even in that outer layer, we can make these product managers happy. And that's what we, what we focus on, but all through a single core and to a set of modules that are, those are immutable basically. So it's not that we have like two types of Weaviate or something. It's just one Weaviate where we support all these use cases.
Yeah, and I mean, like for those of us who really want to go deep into detail, and like the analogy that just kind of came to my mind is that if you take MySQL or some SQL database, right? When you choose the type of the field that you index, right? And you're thinking, okay, it's going to be a B-tree, or it's going to be full text, or it's going to be some other data structure that SQL database offers to you, that's when you start asking questions. What is the trade-off, right, of choosing that version or the other version? But you may also kind of just index the data and then kind of solve your use case first, right? And only when your product manager comes back to you and says, hey, why is this slower than yesterday? Can you improve? Right?
Exactly. And what I find interesting and important, where we now are in the cutting edge where vector search in general sits, is that yes, it's very important to talk about, to be transparent about, to share about, or not share, depending on your open or closed strategy, about how these things work, what kind of algorithms are used under it, etc. That is very important, and that's also, as you mentioned earlier, something that we are very active in. By the way, not only so for example, my colleague HN is doing that from the core of Weaviate, but my other colleague Laura is more doing that from GraphQL perspective, and like how can you build these queries within Weaviate, etc. But I think it's also important to, if we take your MySQL example, what do people use MySQL for? Or in our case, what do they use vector search for? And how can I communicate to these people who have absolutely no idea what an ANN algorithm is? And I think that those are the three pillars that we stand on. So the core, the interface, and the use cases. And we try to cover these three pillars within SeMI based on one code base.
Yeah, that's fantastic. I mean, what you do there, and like I will link the like what is it, selfish plug, so the blog post that basically explains kind of few details of 6 vector databases, couple of which are closed source, the rest are open source. You can actually see for yourself like what is happening there in those databases, and then so much material there, and like don't go too technical yet, kind of stay in the use case part, and kind of like and I hope we can like as a community collaborate more in bringing these use cases, kind of highlighting them. I just alluded to similarity code search, or encoding some software viruses into that representation, and then searching similar viruses when you need to do that, and you're like, yeah. So I mean, there are so many use cases that it's our job in many ways to connect, and you're doing a great job there, really.
Thank you.
To connect the use cases with the tech, right? So like, don't fixate on the tech yet, because tech is going to improve over time. There will be new cool algos, by the way, the billion scale competition going on. There will be probably new algorithms, right, that will beat in performance. And then eventually performance will stop mattering in a way, right? Like it will be something else. It will be like, okay, what can I do with it?
Yeah, so and let me, if I may give a quick metaphor there. I mean, probably this metaphor is used many times for the technology, but just to make it as well. It's like, the other day I ate at a great restaurant with a friend of mine. We had great, amazing food. It was a great atmosphere, great food, everything, right? So that it would be the metaphor, the use case that you have. But my friend, she said, like, I actually want to know how they make this food. So she also bought a cookbook, right, with the recipes in it. So now she could go into the book and she could actually go even a level deeper and actually see how the chef prepared the dishes, which is fine. I was not necessarily, I just wanted to have like some nice food and a nice glass of wine. She wanted to know a little bit more. And I think if we're smart about this, and I think also that is the where open source business development is now in 2021, almost 2022, is that you can actually cater that to that whole stack if you do that smart, and because they click into each other. So so the point is, like you said, like I don't think that the technology and talking about technology is also very important, but I don't think it's the only thing we should talk about. I think we should make sure that we talk about both and that they're constantly aligned. That's also within how we talk about Weaviate internally. That is aligned. But people use different words and different ways to describe the technology. So people that are helping me on the business development, they use different words. They never talk about HNSW like the people in the core tech team do, but they have a great understanding about the use cases that are being solved. So, and I think that all needs to come together, and we are in an amazing point in time where that's happening for vector search. So I think that's just amazing. And by the way, kudos to you as well, right? So you're carving out your own niche as well there. So good for you. That's nice. That's cool to see.
Yeah, being independent kind of in this field, because it also opens doors to talk to guys like you, really. And like if I was your competitor, maybe you wouldn't want to talk to me necessarily, not on topics like this, right? It would be a different discussion.
It's a
And
different
so,
discussion. Yes. Yeah.
and at the same time, as I said in the first episode, I'm actually educating myself a lot on this. So in the process of this, I hope to share, the learnings and benefit everyone, including myself. So that's the way to go forward. So kind of on the open source side, right? So I'm open sourcing what I
Exactly.
learned. And yes,
Exactly.
hey Bob, so you really shared so much insight in what you do on the product side in at Weaviate as well as technology. I want to drill into more into this kind of philosophical level, why you do this. And when I say why, like I mean you personally, right? And that
Yeah.
probably propagates to your team as well. And we can even ask everyone on your team why you guys do this, right? But you are the visionary, you are at the core of this. Like what brings you to this field? You're at the forefront of it.
Yeah. So it's like that's a great question, by the way. So thanks for asking. So um, so when I was working on just experimenting with these models and these representations, and I started to do research on actually how big is this? How much unstructured data is there actually that we could potentially help it? Then I found out that this was so big, and at some point I was just walking down the street, literally, and if you just walk down the street, it's like like in the Matrix when Neo sees everything like that he sees Matrix. I was like, wow, every company that I see, every truck that I see driving by, an airplane that I see coming over, a warehouse that I see, they could potentially use Weaviate. And that's that dream that I just can walk down the street and it's like, oh, do you see that truck there? Yeah, that company uses us to do X. Oh, you see that hospital over there? Yeah, they use us to do Y, etc., etc. And that is such a thrill to be in a new niche and trying to build that product and try to build it a solid product and bring that to that new product to people, solve new problems. That is a personal driver, plus something that is just something that I'm personally very interested in, and that's something that you already, I guess, noticed by the way that I present my answers, and that grew over time, is that I became interested in that layer between you have the tech and how people use it. There's like this overlap there. I'm interested in that overlap, and like how do people use the technology? How does that create value, and how can we bring that value to them? And how can we capture some of that value? And that is something that I'm extremely interested in. And this is just SeMI Technologies and Weaviate as a product is a vehicle do that. So it's like, if we then just, if we think big and we think about this new niche, the new database technology, then let's just go all in and just see, how far we can bring this. And there's way more to say about this, but it's such an exciting time to work in this, and so that's my personal reason why I do this. And so that.
Yeah, since you are so big on use cases, is there a specific use case that drives you, that gets solved? Maybe it wasn't solved yet, maybe it was already solved. By the way, in your videos, like you always kind of quite frequently you say, okay, imagine a wine store, right? And I'm thinking probably there is a good wine in Holland. I should, when I travel, let's get together and drink some good wine. But like, is that the use case that drives you? Is there something else that you think could be solved by Weaviate?
Oh no, so it's
wasn't.
Yeah, so the what drives me is there are certain use cases that could be, I think, and I'm now doing this from the top of my head, that you could look at them from the perspective of size, so that that big, large corporates are working with Weaviate trying to solve problems, that I go like, this is amazing that they use this, right? That is something that on one hand that drives me. On the other hand, what drives me is that people who are looking at Weaviate to use it to where it has an impact in people's lives. So that can be medical use cases, or even even goes as far as the HR example that I gave, right? And I'm a little bit vague about these use cases because we're still working on them. But so when they're big, or when they have an important positive impact on people's lives, that is amazing. So if I present to certain people results for these big use cases, and you see these, people, their eyes, they go open, they go like, wow, can you actually do that? That's amazing. That is the most, that's the coolest thing that's around. And there's also there's something in, and I don't want to sound too vague about it, but that's something exciting about with machine learning, I guess, and especially with NLP. So one of the things that we are working on, and we hopefully going to release very soon as a demo data set, is that we loaded the complete Wikipedia into Weaviate, just the whole thing. And so we're now talking about almost 100 million paragraphs. And I watched an Anthony Hopkins movie the other day, and I typed into Weaviate just in the GraphQL API, like, which actor played Hannibal Lecter or something. And then in a few milliseconds, it says Anthony Hopkins. And I go like, whoa. And that is so cool if that actually works. And if that happens, that is that just gives me a thrill. And so I would say these three things are why I'm doing it.
Yeah, that's super exciting. It's like, like if I was asking the same question to me, then the word semantics, right? The similarity,
yes,
that would drive me, because I actually did my PhD in machine translation, and my supervisor developed a semantic parser. It wasn't syntactic parser, and I cannot still find an analogy on the market for this work. But like, it was driving me that the way he was explaining this is that, hey, I really now read Tolstoy, with my parser every single day, right? And it fails, I fix it, it fails, I fix it. But sometimes it amazes me, because Tolstoy tends to create so long sentences that they can take several pages, in Russian, right? I don't know how it looks in the translation, by the way. I've never seen the translation, but in the Russian source. And Tolstoy has rewritten his book 9 times. His books, it's like several books, right? Like the War and Peace, I mean. And like, so like, he was basically compiling the language using his parser, and he was fascinated by this. Like, okay, this is the semantic layer. And I was constantly thinking, I defended my thesis in 2011, and I was thinking, okay, how can I apply this tech in real life? And it was very difficult, because this parser is kind of implemented in Forth, and I don't code in Forth. I don't know if you heard of this language. It's like, it's used in the industry. It's high
Yeah.
performance and like, but it's functional. It's not.
Mm.
Yeah. So like you can express many things with just one single word, and then it just unwinds there behind the scenes. And you're like, okay, how do I debug this? Right. So, and there was a port to Java as well done by another student. But I was kind of constantly fascinated by this field. Like, how can I bring semantics into the world of numbers and into the world of like, well, let's put it inverted indices for that sake, since you mentioned it many times.
Yeah. No, but I like this actually very much what you're saying, and it's like and this goes again a little bit out of the realm of the technology. I mean, you use the technology, but it goes out of it. I remember that there was before the whole pandemic hit. There was like I was speaking at a conference in London, and they were so nice to book me at the or to have me at the large stage. And so I had like this big screen, and I'm talking about Weaviate, and I'm giving a demo, and I could see the first few front rows. And that what you said before, the Q&A example. So I give a Q&A example, and I just give a real demo. And what I always do is then the moment when I present to an audience and I click like to execute the query and get the response back, then I always look at the people that I'm presenting to. And you see these people go like, they sit like in a room, they're just watching the screen, and they go like, and that's like, and then you go like, that's such a cool thing. So something that we as a team came up with, and everybody participated in building the thing, and then people enjoy seeing that and enjoy using that. That's amazing. That's like yeah, that's just that's just fantastic. So, and language has that additional element to it, right? So that people, there's this how we communicate, and we get closer to have the machines communicate, that we can communicate more natural language based with people. Yeah, that's amazing. So that would be that would be a fourth why of doing it. Yeah.
Yeah, that's fantastic. That's so deep. And like I'm happy that we also connect with you on that topic, of the semantics. When you can park all other items like technology, use cases, product, but the semantics part where we're driving this thing, it's just amazing. And I'm happy for
Yep.
you guys to be doing this. And I think part of
Thank
the
you.
excitement of being at the edge of doing things is also kind of, launching things and like kind of like announcing something. Is there something you would like to announce to our listeners?
Yeah, so yeah, certainly. So I think so one thing that I already mentioned a bit. So we're gonna launch that huge data set, just the whole Wikipedia with everything, and also for people to try it out and to play around with, so that they can see actually how big it gets. And related to that, and we already actually have it in pre-release, but it's gonna be released very soon, just as a standard release, is everything related to horizontal scalability. So that people can now scale from into the millions into the billions. And we're starting to get these kinds of questions in, and we're very close. And it's like, as in like very 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 close, because the pre-release is already out there. And that then goes full circle back to people asking. I get sometimes emails from people like, yeah, so we have like X billion vectors, but you probably can't. I said, well, hold your horses. We probably can. And they go like, but can you also store the metadata? You can also store the metadata. And then people go, they're really excited. So it's just that just keeps going and going and going. And so those are the big two things that I want to share, because there's a lot of people asking for this, and so we're probably going to make a lot of people happy when it's out of the pre-release
Yeah,
phase.
that's fantastic. I mean, it both sound so big. And I'm actually spending my time now figuring out how to scale. I participate in the billion scale competition, actually, by the way. And like I'm waiting with excitement for this release, because I would like to learn things from you guys as well. And like, if you solved it and you open source many things, and you will open source this part as well, so it's amazing, what you do. And I'm waiting with excitement to learn what you've done. So thanks so
Fantastic.
much. And thanks so
Yeah,
much.
thank you.
Thanks so much for your time as well. I mean, we
Of
went
course.
so deep today, and in many areas, and I'm sure we can talk more at some point down the road.
we probably can. And thank you so much for having me. And keep up the great work because you're doing a great, job in the, in the community and in the industry.
Yeah, thanks so much, Bob. My pleasure.
Of
And
course.
see you next time. Bye.
Cool. Thank you. Bye.